In this video, we are going to talk about verifying identities. So just to be clear about what verifying an identity means, that means to prove that the given equation is indeed an identity. So you'll have an equation like this here, right? As an example, this one down here. And somebody says, hey, that's an identity, meaning, right, that no matter what value you plug in for x, as long as all of the expressions are defined at that value, then you will get this side equals this side, right? So when you plug in a number, you'll get some number here. You'll plug in a number here. It will always come out to be the same, right? Assuming that it's an x where these expressions are defined, okay? So remember, not every equation is an identity, right? There's some that only have a couple of solutions or maybe no solution, right? So basically, an identity is an equation for which every number is a solution, as long as the expressions in the equation are defined at that value of x. All right, so somebody says, hey, this is an identity. So basically, this is a true statement, right? And so what it means to verify an identity is to prove, right, that is an identity. You can't really solve it, right, out because, well, you'll have infinitely many solutions, and so that's going to probably be fairly complicated, okay? So what you want to do when you verify an identity, rather than trying to solve it, right, is to use some algebra, simplify some of the expressions in here, and with trigonometry, especially use other identities that have already been verified. And what you want to do is work to change one side of the equation into the other, okay? All right, so it's kind of like saying, hey, I don't believe this is identity, prove it, right? And so you would do some algebra work and use other trig identities to verify that the equation is an identity. So before we get started working on this identity, just some advice for verifying identities. Number one is work on only one side of the identity at a time. On a lot of these, we will just only work on one side of the identity. So we'll pick one side and then work on that side and see if we can boil it down to the other side, okay? It's not like you can't work on both sides. You can, but remember, stick to working only on one side at a time. So that leads into this second point here. Do not confuse verifying an identity with solving an equation. When you go to solve an equation, things that you might do are you might add, subtract, multiply, or divide both sides of the equation, right? You do not want to do that when you are verifying an identity, okay? So don't try to act like you're solving the equation, right? What we're doing is trying to change one side into the other side, right, using known identities and algebraic steps, okay? Simplifying on one side at a time, all right? So don't confuse those two things. When you're working with identities like this, you usually want to start working on the more complicated side, okay? And so that's just kind of common sense. It gives you more things to work with, more things to do over on the side that's more complicated. You want to look for known identities that you can use to simplify. So these identities here are ones that you can just assume are true. They don't need to be verified or anything like that. You just assume that these identities that we've talked about before are set in stone, and you can use these anytime you like. And we'll slowly start adding more and more identities to that list. But for right now, we ought to be able to just use these identities here at the top of the first page. Sometimes combining fractions into a single fraction will help. It's not always what you want to do, right? Every identity is different, right? And there's lots of different types and lots of different things that you might have to do. So this is not automatic, but it's a pretty good indication. Hey, if you've got some fractions there that are being added or subtracted, you might want to go ahead and combine those into a single fraction. And then sometimes converting the expressions that are involved in the identity to sines or cosines will help. Okay. Not always. You don't want to do that every single time, but a lot of times that will be helpful. Okay. One other thing before we start on this first example, and that is the traditional problem of verifying an identity looks like this. It's an equation, right? But we are working with Newton in this class, and so in Newton, these kinds of questions are presented as multiple choice questions. So that means that what you'll have to do is basically, start working on the expression that they give you, and then be looking at the multiple choice questions, the multiple choice answers, and trying to work towards one of those. So it's slightly different here. We know that if we start with the more complicated side, that we are going to be trying to boil it down to sine x minus 1. So that's very helpful, right, in the sense that you kind of know, it kind of tells you what to do. Try and change all of these things into sine if you can do that, right? And so that's helpful. You'll have the same thing on the Newton assignments, but you will have several of those to try to look at. So it is slightly different when you do that on Newton. Okay, so we have this identity that we want to work: cosine x tan x minus secant of the opposite of x equals sine x minus 1. All right, and I want to verify this identity. So I'm going to start over on the more complicated side, which is here on the left-hand side. All right, and the first thing I see when I do that, look at that, is that I have cosine x times the quantity tan x minus secant of the opposite of x. Here I have this opposite of x inside here. I know that I can use the even and odd identities to simplify that. In fact, this one right here, that the secant of the opposite of x is just equal to the secant of x. So that's where I'm going to start. On the first type of identities that we do, to me, it is much easier if the arguments of the trig functions are all identical. That means the stuff that that's inside the trig functions. Here I have x, and minus x. Well, it's a lot better if they're all just x. We can easily change that opposite of x to x by using that identity, the even odd identity for secant. Okay, so next up then I am going to take a look. It's still working over here on the more complicated side. And I have cosine, tan x, and secant x. So what I'm going to do is, looking at tan x and secant x and the identities that I know, I can see I have tan x, right, is sine x over cosine x, and secant is 1 over cosine x, right? And so I'm going to use those two identities. So tangent is sine over cosine. Secant is 1 over cosine. All right, and so that is an example of one of the things that is sometimes a good thing to do, and that is express all of the other trigonometric functions in terms of sine and cosine. If you think about it, right, what we've got to do over on this side is basically get rid of all the cosines, secants, and tangents, and what we want to introduce are sines, right, like sine x, because that's what's over here. So changing tan x to sine x over cosine x does help us, right, in the sense that we introduce a sine, which appears over on the right-hand side. And we get rid of tan, right, which does not appear over here. Okay, we do introduce the cosine x, but we can kind of worry about that later. All right, next up then is looking outside the parentheses here, I have two fractions that are being subtracted from one another, right? And they have a common denominator. So again, one of the other helpful things to look at that you might possibly do is to combine fractions, right? So I can do that because, in this case, pretty easily, because they have a common denominator. So sine x minus 1 over cosine x, to combine two fractions with common denominators, I just combine the numerators. So sine x minus 1. And then I put that over the same denominator, right? That's how you add or subtract two fractions. Okay, and so you can see that's looking pretty good. Over here, I have sine x minus 1. That is exactly what I want to have over on the right-hand side. And I do have these cosines here, but I can easily kind of get rid of those in the next step, right? If I can kind of think about writing this cosine x as cosine x over 1, you can see I'm multiplying two fractions, right? I'm multiplying cosine x over 1 times the fraction sine x minus 1 over cosine x. And so I have a common factor of cosine between the numerators and denominators here. So that can be canceled out, right? So cosine x goes into itself one time. Cosine x in the denominator will go into itself at one time. All right? And so now then I can go ahead and multiply these fractions. 1 times sine x minus 1 will be sine x minus 1. And on the bottom, I have 1 times 1. So that would be sine x minus 1 over 1. Well, anything over 1 is just itself. So I'm just going to leave it just like that. Okay. And you can see that these sides now match up. All right. So this identity has been verified. Okay, so it is true for all real numbers x, where x, tan x, and secant of opposite x are defined. Okay, and so notice one other thing, right? That I'm not trying to solve for x here, right? All I'm doing is working on one side at a time, and in fact here I only worked on the left-hand side, right? And I tried to boil this down. The left-hand side, working only over here to transform it into the right-hand side, and I was successful, right? So the identity is verified. A lot of times people will get confused about what they're supposed to do when they verify identities. They'll say, well, what's the answer, right, to the thing? And really, again, it's not really an answer. You are basically providing an argument that this is true. So you're saying, hey, this is true. It's always true that these two expressions are equal to each other when they are defined. And then somebody says, no, I don't believe you. Show me. Show me why they're true. And this is a little demonstration as to why they are the same. Because this side can be changed to this, which can be changed to this, which can be changed to this, which can be changed to this. So they are equal to each other. All right, and so that's sort of the process that we will use to verify identities. And we will do some examples in the subsequent videos.